Hey physicists, let's go ahead and solve our Simon the Cat problem. Okay, and let's say we have the ground here, Earth down here. I'm not a good cat drawer. Let's see, the cat was kind of just laying on the ground like that. Okay, and leash on the cat. We didn't see the person, so I won't worry too much about that. Okay, and so things we knew is that it looked like the cat was moving at a constant velocity. Okay, and was sliding along the ground. Now, constant velocity is going to tell us, I spelled that out. Of course, constant velocity is going to tell us that the sum of forces is going to be equal to 0. Another way of saying that is net force is going to be equal to 0, or that the forces are balanced. Remember that from once upon a time? Okay, let's go ahead and identify things. Well, between the cat and... So we'll start with, of course, our non-contact forces between the cat and the earth. We've got gravity. From the ground and the earth, we've got gravity. I won't consider that the leash weighing a whole lot there. Now let's take a look at our contact forces. How about normal force? First, and we'll see, yeah, there's a normal force between the ground and the earth. Normal there. And then between our cat and the ground, or else it would fall to the center of the earth. Next, let's take a look at, how if we take a look at tension. Okay, tension. But the only place I see tension is between, say, this leash and the cat. If we knew the person was over here, there could be some tension between the two there. And the last one we look at is friction. Not sure what's happening there. Sorry about that. And, of course, we saw that between the cat and the grass as it was getting dragged along. Looks like we're ready for our force diagram. Let's go ahead and enclose our object, our cat in this case. Like that. We'll take our cat, reduce it to a single dot here. We'll go around here. We see gravity, so we have a... I'm going to add the additional notes on here. Force of gravity, or by notes I mean the subscripts. Force of gravity on the cat from the earth. Good, we're taking care of that. How about that normal force that's keeping it from falling to the center of the earth? So force normal on the cat from the ground. And we know that those are equal. Keep on going around here. We see tension force. Cat's being pulled to the left. So a force of tension on the cat from the leash. And the last item we see here is friction. We can see that friction and resisting motion. I'm assuming Simon's being pulled that way. So we have a force of friction, the type of force, on the cat from the ground. And again, at constant velocity, so we know forces are balanced. So the left and right forces are of equal magnitude in opposite direction. Okay. And just a quick note on this one, even though they're of equal magnitude in opposite directions, this is not a force pair. Why? One, there are different types of forces. One's friction, one's tension. The other thing is that force pairs work on different objects. Both of these are working on the same object. So let's say I did want to identify the force pair here. Okay, if I was drawing a force diagram for the leash itself, there's a little bit of gravity and a little bit of normal force. Maybe it's being held up by the person. But the thing is that we're going to have tension force. We're going to have a force of tension on the leash from the cat. That and that are going to be our force pair. Notice force of tension on the leash from the cat, force of tension on the cat from the leash. And then maybe out here we have the force of tension on the leash from the person pulling it.